Hello, I want to give a brief introduction of my final project. I will now start with introduction of the dataset. The data is collected from the Seoul Public Data Park website, and it contains rental bed count for each hour from December 2017 to November 2018 in Seoul City. It also contains some weather conditions like temperature, and some information for the date, like whether the day is a holiday. And here is all the attributes in the dataset. I downloaded this dataset from UCI Machine Learning website. Here's the link of the website, and also here's a screenshot of the web page. The target variable is rental bed count for an hour. I chose this dataset because rental beds become more and more common in many urban cities. It's important to make the bag available and accessible to the public at the right time and reduce the waiting time for people. Also, I think this research could help decrease costs of management and maintenance of the rental bags. After I loaded the dataset, I first checked the structure of the data and get basic statistical information to get an overview of the dataset. Then, I detected if there is any missing value or outlier in the dataset. I set this score bigger than 3 as standard to detect outlier. Also, I implemented Pearson tests and Spearman tests to check the correlation between numeric variables. At last, I checked the distribution of all variables using scatter plots of metrics. For mode building, there was some necessary transformation need to be done. I will show you my R code of these transformation steps. I added a new feature called heat index that could better describe the effect of temperature and humidity for human feeling. Here's the formula of this feature. And here's the code to mutate it to the dataset. Here's the summary of this new feature. Since there's no missing value in the dataset, I randomly added some missing values and imputed them with mode or mean depending on the data type. And here's the code of adding missing values to holiday and temperature features. And also, here's the code of imputing the missing data. For KNN regression, I normalized all numeric features and encoded all categorical features to dummy code. I used the max-min method to normalize numeric features. For multiple regression, I must make sure all numeric variables is in normal distribution. So I tried square root and log method and check the distribution of results for the two methods. Some variables can't be transformed to even close to normal distribution, so I dropped them when create dataset for building multiple regression. And here's the distribution of numeric variables that could be used to build multiple regression. I choose KNN regression, regression tree, and multiple regression for modeling. The target variable is numeric, so the models must be regression model. Since most of the variables in the dataset are numeric, KNN regression and multiple regression is suitable. Regression tree fits this analysis as well, since there are not too many requirements to the data for implementing decision trees. And this dataset also doesn't contain too much variables. I will show you my R code for model building and evaluation. For KNN regression, I created a function to build KNN model, make prediction, and calculate MSE. And here is the function I built. For predicting, I also built a for loop in order to detect the k-value with smallest MSE for predicting the testing dataset. And here is the for loop. And we can say here's the relation between k and MSE value. And the best k and MSE of the best k model is shown here. For regression tree, I first built a tree, used the whole training dataset. And here's the code. And then I created a bagging model with 100 bootstrap replication number. Here's the bagging model. And then I compared the MSE of two methods that predicted the testing model. And here's the result. We can see that the MSE of bagging is much smaller than the single tree model. For multiple regression, I first removed the temperature feature that has collinearity with other predictor. Then I implemented stepwise backward elimination to remove non-significant predictor. However, the MSE values didn't have big difference for different multiple regression models. I used every single model to make prediction, and calculated the mean of the three results as ensemble prediction. Here's the function to make prediction of three single models and the ensemble result. And then I calculated MSE for the three single models and ensemble model based on the validation dataset. I improved the ensemble model with the weighted average calculation. I gave the single model with the smallest MSE a weight 2, and other two single models a weight 1. Here's the new function of ensemble model. And here's the weighted average part. And here's the MSE of all models. We can see that the regression tree has the smallest MSE. And the ensemble model actually improved with the weight average. Here's the original ensemble model MSE, and here's the improved ensemble MSE. I think the ensemble model performed about a medium level. The multiple regression has the worst accuracy according to the MSE, and it should be evaluated and improved more deeply. According to this project, I learned a lot about regression model and data preparation steps. Especially, I learned how to build regression tree model and how to implement bagging for the tree. Decision tree is really powerful and easy to build since it doesn't need much data preparation. Thank you for listening.